Hello and welcome to today's video. My name is Reza and you're watching the guide to the 7th set of practice problems. Guys, the world is changing and in today's world, you need to know how to write programs. What are you doing here?
I just wanted to point out something to your audience.
Okay, go ahead. Tell them, but be quick because they're under a lot of stress.
Okay, I promise I will be quick.
Unfortunately, guys, we're not in an actual classroom these days. We cannot sit and talk about future. Because of the COVID-19, we have to be online and I didn't get a chance to meet most of you guys. But what I wanted to talk to you guys about future, the future that I see. There might be a day that degree wouldn't work for you. Your knowledge would work for you. Rather than just focusing on finishing a course, to just complete your task in the course and finish tests or assignments or quizzes, try to learn. Don't pass on topics that you don't fully understand them. Try to go to details. You're building your foundation of knowledge in engineering. I highly recommend you to make this foundation as deep as possible. Because soon in future, you might wanted to start your own business. You wanted to work for a company that wanted to pay you a lot for your knowledge. Then you have to work for that knowledge. I wish I had someone to tell me this when I was starting engineering on the early days. But I'm telling you guys, this is time to take your time and focus on the material that you're receiving. Awesome, great, thank you. Let's go ahead and continue the video. Have a great day, guys. In today's video, we're going to go over 3 practice problems. In the first one, we're going to calculate distances using function. In the second one, we're going to write a code that transfers Cartesian coordinate to polar coordinate. And this is useful to engineers, guys. And the third problem, which I like it a lot, and I'm still using it until today, it's writing a code that uses Newton's method to solve equations. To watch this video, you need to know about pointers and functions. You also need to know how to pass arguments using their address to a function. Link to those videos will be available in the description below. Like always, link to the timestamp of different problems will be available in the description below, so feel free to jump between the questions.
Problem number 1. If you're in a city and have to walk from where you are, having planar coordinate of 0, 0, to a destination having planar coordinate of x and y, then there are 2 ways to compute the distance you have to travel. One is called the Euclidean distance, which is r1 equal to square root of x squared plus y squared. Note that this distance might require you to cut across lawns and through buildings. There's another way to measure distance called the taxicab distance, which is r2 equals to absolute value of x plus absolute value of y, which is the distance a taxicab would have to travel along the city blocks. Write a program which reads the destination coordinates x and y and calls a single function distance, which computes both the Euclidean distance and the taxicab distance. The main program, not the function, must then print both distances to the screen. Your program's input and output should look like what you can see on the screen. You can run your program twice using distances 2 and 4 and -3 and 4.
Here are the steps I should take to finish this program. I'm going to focus on the function declaration step at this moment. I need to have a function which returns 2 arguments. At the moment, considering the material we have covered, the easiest way is to use pointers, as we cannot do it using the return statement. The clean way to do it is to create 2 variables in the main function, then send the address of these 2 variables to the function. In this way, I can modify the value of the local variables r1 and r2 using my function. If you don't know why you should do that, there's a video called Pointers and Functions. You should watch that video first. I'll put the link in the description below. I will go back to step 4. If I'm using pointer to return both distances, I can go ahead and declare the function as void. Regarding the input arguments, I need both x and y from the main function, and the address or the pointer to the variable r1 and r2. Let me show you how the function call would look like. I would call distance. Of course, there's no point in using assignment operator. The input arguments are x and y. The rest of the input arguments would be the address of the variable r1 and r2. Let's quickly jump to step 5 and implement the function. The steps I'm going to take to develop the function is listed on the screen. I'm going to create two local variables r1 and r2, then calculate the mass using sqrt and fab function available in the mass library. Next, I'm going to dereference the pointer so I can access the value. If you don't know what is dereferencing, I have a video for it. The link will be available in the description below. Then assign R1 and R2 into PTR R1 and PTR R2. For testing purposes, I'm going to hard code x equal to 2 and y equal to 4 in step 2. Let's put a breaking point on the function call and go to the debug window. In the debug window, go to the debug menu, then window, then memory, and then memory module 1. Now that we can see the memory clearly, let's type the memory address of the variable r1 and see what is happening. I'm just going to type %r1 and then enter. You see that the float has not been initialized yet, which we know that. If I step into the function by pressing F11, guys, be careful here. The float r1 and r2 here is different than the one we had in the main function. If I restart debugging, you guys can see that. Here's the address of r1 in the main function. And if I step into the function, and here the address to r1 into the distance function. The memory address of this r1, local variable of the function distance, is completely different than the r1 I had in the main function. Okay, let's move on. If I step over this line, the red code shows that the value of r1 has just been modified. On the next line, the value of r1 in the main function would also be modified. Let's restart debugging, open the address of r1, then a step over. You can see that the value of r1 changes when you step over the function. Okay, great. You should be easily able to finish the code. One thing to point though, to optimize my function, I can remove the unnecessary local variables r1 and r2 and assign the result of the mass operations to the dereference pointer. Now the function would be much more clear. I hope these hints help you to solve the problem. Let me know if you need help or if you have any question.
So let's go to problem number 2. The polar coordinate r and theta of the point x and y in the plane can be computed as follows. R equal to square root of x squared plus y squared, and theta would be r cosine of x over r if r is greater than 0 and y is greater than 0, minus a cosine r cosine of x over r if r is greater than 0 and y is less than or equal to 0, and if r is 0, theta would be 0 as well. Write a program called x2polar.c, which uses a function called polar to compute the polar coordinate of a point. Your program must consist of a main program and a function called polar. The function polar takes the x and y coordinates of a point as arguments and computes the polar coordinate r and theta. The main program opens the output file polarout.txt for appending mode A, reads the x and y coordinates from the keyboard, calls polar, and then writes both the x and y coordinate and the corresponding r and theta polar coordinates to the output file. Run your program 4 times with x and y as follows: 2 and 2, 1 and -1, 0 and 1, and 3 and -1. The first and subsequent lines of your output should look like what you can see on the screen.
Let's break this into different steps. In step 1, declare your variables in the main function and open the output file for appending. Step 2 is to prompt the user to enter x and y and scan them. Step 3 is to call the function polar to compute r and theta. Step 4 is to declare the function polar. Step 5 is to implement the function. In the function implementation step, we need to declare the local variables, then calculate r using sqrt function available in the mass library. The next step is to find theta using an if analysis structure, And the final step in the function implementation is to return r and theta by dereferencing the pointer you get as the input. Step 6 would be append the output to the file, and as always, step 7, which is the last step, is to close the file. I'm sure you can easily tackle the problem following the steps. Let's move to the next question.
So let's start on problem number 3. In calculus, you will learn an algorithm called Newton's method for finding the roots of an equation fx equal to 0. The technique starts from an initial guess of x1 and computes a next estimate x2 by using the formula that you can see on the screen. We then apply the procedure again, starting from x2 in place of x1 in the right hand side, and we keep repeating this until successive estimate differ by less than some preset tolerance. Note that each repetition is called an iteration. Write a program called root.c which find a root of the function fx equal to sine x minus 2 times e to the power of negative x in the vicinity of the user provided starting guess x1. Your program must consist of a main program which opens the output file root.out.txt for appending mode A, reads the initial guess x1 and desired error tolerance tol from the user, calls the function Newton described below, and writes the estimate root and number of iteration requires iter to the output file. Aside from the main, your program must consist of the following 3 functions. F, which takes an argument x and returns fx equal to sine x minus 2 to the power of 2 times e to the power of negative x. Df, which takes an argument of x and returns the derivative of the function I just showed you. Newton, which takes the initial guess x1 and the desired tolerance tol as arguments and calculates both the estimated root and the number of iterations iter required to find the root within the desired tolerance. Assume that the tolerance in this case refers to the absolute tolerance. For example, equate when the absolute difference of x2 minus x1 is less than tolerance. Here's a plot of sine x minus 2 to the power of e to the negative x looks like. And now you can see where exactly the roots are located. There are roots near 1 and 3. Run your program twice with the starting values of 1 and 3, both times with an error tolerance of 0.0001. Your output should look like this, as you can see on the screen. Let's jump to Visual Studio.
Here are the steps I would like to follow to tackle this problem. In step 1, I'm going to create some variables. First, I'm going to create a file pointer for output file, and I will also open the file here for append. I need an initial estimate, so let's say float x1. I need a float to store the root. I also need a float to store the tolerance, and finally an integer to store the number of iterations. The next step is to prompt the user to enter the initial estimate of the root and the tolerance. In the function call step, I want it to look like this. Root equals a function Newton, and the input arguments initial x, tolerance, and the memory address of the variable iter. In the function declaration step, the function returns a float, so the function signature is float, and then Newton, and then it takes 2 floats and an integer pointer as input parameters. In the function implementation step, I would like to break it into different steps. So first, to declare local variables, compute the new estimated root, then compute the difference of the new estimated root with the previous estimated root, increment the iteration counter, set up variables for the next iteration. So the 4 steps that I just mentioned, they need to be repeated until difference is less than tolerance. And the final step in the function is to return the root and the number of iterations. In this step, we need a variable to store the next estimate of the root. We also need a variable which stores the absolute difference between x1 and x2, and a local variable for storing the number of iterations, which needs to be initialized by 0. Definitely I need a loop. I'm going to use while loop as the number of iterations is unknown to me. For the condition, I can put until diff is less than tolerance. Then I have to initialize diff to a number higher than tolerance to make sure the first loop would run. I know the tolerance is going to be less than 1, so I'm going to initialize it to 1. Then let's compute the next loop using provided formula. I'm going to create two functions, f and df, to simulate the behavior of the formulas provided in the problem. Both functions take a float number and return a float number. The function f is the formula provided for the question and the problem, which is sine of x minus 2 times exponential of negative x. One thing to note here though is that you see that not only I can put the calculation in front of the return statement, but also I can put function calls. As a matter of fact, they are the same. When you add two arguments together, you're basically using a function. So any operation in C is basically a function call. The next step is to update difference, and then update the iterator counter, and the final step of the loop is to update the variable x1 for the next loop. The next step is to return the result. In the next step, in the main function, I'm going to print the result both on the screen and to the file. Then let's close the file. Let's compile and run the code. Wanted to mention you guys here is, instead of creating an integer iter and initialize it with 0, you could have just go ahead and use the address of the pointer to the iterator to the main function and work on that one. But you need to be careful that you need to dereference it. So let me dereference it here, and then put the initial value as 0. So be careful here. Now I have to change it here as well. And definitely I have to dereference it because we wanted to increment the value of that PTR. We don't want it to increment the address of the variable. But this is wrong because this will happen first and then will be dereferenced. So in order to dereference a value and then increment it, don't forget to put it in between the parentheses. And then we don't need this line of code anymore. And the iterator in the main function will automatically be updated.
Thank you guys for watching today's video. Let me know your feedback and don't hesitate to reach out if you need any help. See you in the next video.